Hello everyone, today we're going to talk about the nuclear reactions in space exploration. You might actually wonder what this topic actually means. So, nuclear reactions plays a pivotal role in space exploration, powering spacecraft, generating electricity, and enabling scientific discoveries beyond the confines of Earth. From propulsion systems to power sources and scientific instrumentation, nuclear reactions provide the energy and capabilities necessary for humanity to explore the cosmos. This introduction will provide a brief overview of how nuclear reactions are utilized in various aspects of space exploration, highlighting the importance in advancing our understanding of the universe and enabling ambitious missions to distant planets, moons, and beyond. Before that, I'm going to discuss the importance and significance of this topic in modern physics. Firstly, they power stars, including our own sun, providing the energy necessary for life to exist and shaping the evolution of galaxies. Additionally, nuclear reactions drive processes like fission, which could potentially provide a nearly limitless source of clean energy here on Earth. In modern physics, studying nuclear reactions help us understand the fundamental forces and particles that govern the universe, contributing to fields such as astrophysics, particle physics, and even applied technologies like nuclear power and fusion energy research. We completed this assignment by conducting a comprehensive search of academic journals. We also utilize online resources, educational websites, and documentaries regarding this topic. We also study the lecture materials provided by our Madam Sally.
Next, researching nuclear reactions in space exploration poses several challenges primarily due to the complex nature of both nuclear physics and space environments. Here are some challenges and potential solutions. Firstly, limited access to data. Space exploration involves distant and often inaccessible regions of the universe. Gathering data on nuclear reactions occurring in these environments can be challenging. The solution is utilize remote sensing technologies such as telescopes, spectrometers, and detectors to observe and analyze radiation signatures, neutrinos, and other particles emitted from nuclear reactions. Additionally, spacecraft missions equipped with specialized instruments can collect data directly from specific locations.
Explain more about the chosen concept, law, or theory in modern physics and its content about nuclear reaction in space exploration. One of the crucial concepts in modern physics relevant to nuclear reaction in space exploration is the theory of nuclear fusion. Nuclear fusion is a process by which multiple atomic nuclei join together to form a heavier nucleus, releasing a significant amount of energy in the process. This is the same process that powers the sun and other stars. In space exploration, nuclear fusion is of a particular interest due to its potential as a highly efficient and a powerful energy source. The immense energy released during nuclear fusion reaction can provide the necessary population for spacecraft to travel vast distance in relatively short amounts of time. This is especially important for deep space exploration missions, where conventional chemical population systems are not feasible due to their delimited thrust and fuel capacity. Fusion population systems represent one of the most promising means of using nuclear fusion for space exploration. By producing thrust with the energy released from the nuclear fusion reactions, this system enables spacecraft to travel at speeds much faster than those possible with conventional rocket propulsion. The importance of nuclear fusion in space exploration lies in its ability to enable faster and more efficient travel to distant destinations within our solar system and beyond. By reducing travel times and increasing payload capacities, fusion-powered spacecraft could revolutionize our ability to explore and colonize other planets, moon, and even interstellar space. Example that we can include is nuclear power in spacecraft. Nuclear power sources such as radio-stopped thermoelectric generator or RTGs and nuclear reactors are used in spacecraft for long-duration missions. Mission to distant or dark regions of space and mission requiring high power levels. RTG utilize the heat generated from the decay of radioactive isotopes such as plutonium-238 to produce electricity. Nuclear reactors, on the other hand, use controlled nuclear fission reaction to generate heat, which is then converted into electricity during thermoelectric or Stirling-style generators. Next is fusion in stars. Stars, including our sun, generate energy through nuclear fusion reaction, primarily converting hydrogen into helium. In the core of a star, high temperature and pressure cause hydrogen nuclei to fuse into helium nuclei, releasing enormous amounts of energy in the process. This energy is what makes stars shine and powers various phenomena in the universe. Application in daily life. While the direct applications of nuclear reaction in space exploration may not be apparent in daily life, but the technologies developed for space exploration often find practical application on Earth. Here the example: medical imaging and treatment. Techniques developed for space exploration, such as radiation monitoring and imaging technologies, have been adapted for medical use. For instance, technologies initially designed to detect cosmic radiation in space are now used in medical imaging devices like PET scanners. Additionally, radiation therapy techniques developed for astronauts have been applied to treat cancer patients. To conclude, while the direct applications of reactions in space exploration may not be widespread in daily life, the innovation and new technologies stemming from space exploration efforts often have far-reaching benefits and impact various of aspects in society and industry.
Recent advancements in nuclear reactions or space exploration have focused on several key areas, including propulsion, power generation, and scientific research. However, along with these advancements, there have been controversies surrounding the use of nuclear technology in space. Here are some notable developments and controversies. First advancement is nuclear thermal propulsion, also called as NTP. NASA and other space agencies have been actively researching NTP systems, which utilize nuclear reactors to heat like a propellant, like hydrogen, providing high thrust and efficiency compared to chemical rockets. Recent advancements in material science and reactor design have improved the feasibility and performance of NTP systems, potentially enabling faster and more efficient interplanetary travel. The controversy that can be found is safety concerns. The use of nuclear technology in space raises safety concerns due to the potential risk associated with radioactive materials and reactor accidents. Critics argue that accidents during launch or re-entry could result in the release of radioactive contaminants, posing risks to the environment and public health. Ensuring the safety and containment of nuclear materials throughout the entire mission life cycle remains a significant challenge.
Next is self-development for a career in space exploration. Let's start by discussing the potential careers to nuclear reaction in space exploration. There are certain careers, which is nuclear engineer, spacecraft propulsion engineer, radiation protection specialist, nuclear physicist, and aerospace system engineer. For the first one is nuclear engineer. Nuclear engineer play a crucial role in designing, developing, and maintaining nuclear propulsion system for spacecraft. They ensure the efficient and safe operation of nuclear reactors in space missions. The next is spacecraft propulsion engineer. These engineers specialize in designing and operating propulsion systems powered by nuclear reactions. They work in optimizing thrust, efficiency, and reliability of propulsion systems for long-duration space missions. The third one is radiation protection specialists. Radiation protection specialists are responsible for ensuring the safety of astronauts and equipment from radiation exposure during nuclear-powered missions. They design shielding systems and implement safety protocols to minimize radiation risk. Next is nuclear physicists. Nuclear physicists conduct research on nuclear reactions and their applications in space propulsion systems. They contribute to the development of innovative reactor designs and study the behavior of nuclear materials in space environments. The last one is aerospace system engineer. Aerospace system engineer collaborate in the integration and testing on nuclear-powered propulsion system into the spacecraft. They ensure the compatibility and functionality of nuclear systems with other spacecraft subsystems. Let's move on to the skills that required in these careers. The first one is proficiency in nuclear physics and reactor engineering. A strong understanding of nuclear physics principles and reactor engineering concepts is fundamental for designing and operating nuclear propulsion systems. The next one is thermodynamics and fluid mechanics. Knowledge of thermodynamics and fluid mechanics is essential for optimizing the performance and efficiency of propulsion systems in the vacuum of space. Next is simulation of modeling software proficiency. The ability to use simulation and modeling software is crucial for designing and analyzing nuclear reactor systems, predicting their behavior under different conditions and optimizing their performance. Other than that, there are space mission design and spacecraft dynamics. Understanding space mission design principles and spacecraft dynamics is vital for integrating nuclear propulsion systems into spacecraft and ensuring their compatibility with mission objectives. The last but not least is attention to detail and safety protocols. Attention to detail and commitment to safety protocols are critical for ensuring the safety of astronauts and mission success in the presence of nuclear materials and radiation hazards. The significance of continuous self-development. Continuous self-development plays a significant role in careers related to the nuclear reactions in space explorations. Keeping pace with technological advancement. Space exploration technology evolves rapidly these days, and professionals must stay updated with the latest development to remain competitive in the field. Besides ensuring safety and regulatory compliance, staying abreast of safety protocols and regulatory requirements is essential to ensure the safety of astronauts and compliance with international regulations governing nuclear materials in space. Last but not least is adaptability to changing environments. Space missions may involve working in diverse and challenging environments, and continuous self-development equips professionals with the adaptability and resilience needed to thrive in dynamic conditions.
Pursuing in a career in modern physics can be intellectually rewarding and contribute to groundbreaking discoveries, but it also presents several challenges. Here are some common obstacles aspiring physicists might encounter and strategies to overcome them. Firstly, highly competitive field. Modern physics is a highly competitive field with limited academic positions and research funding available. The competition for tenure-track, faculty positions, and prestigious research grants can be fierce. The strategy is differentiate yourself by excelling academically, conducting original research, and building a strong publication record. Seek out mentorship from experienced researchers and collaborate with colleagues to expand your network and opportunities. Be persistent and resilient in the face of setback and consider alternative career paths in industry, government, or academia outside of tenure-track positions. Secondly, work-life balance. Pursuing in a career in a modern physics can be demanding with long hours spent conducting experiments, analyzing data, writing papers, and attending meetings. Balancing work commitments with personal life and maintaining mental and physical well-being can be challenging. The strategy is prioritize self-care and set boundaries to maintain a healthy work-life balance. Practice time management techniques such as prioritizing tasks, setting realistic goals, and delegating responsibilities when necessary. Seek support from friends, family, and colleagues when needed. And don't hesitate to ask for help or seek professional guidance if struggling with mental issue. Thank you.
With that, as humanity continues its journey into the cosmos, nuclear reactions and radioactivity will remain indispensable tools in our quest to explore, understand, and ultimately inhabit the vast reaches of space. Last but not least, I would like to thank my fellow groupmates for their participation on completing this presentation, and as well as Madam Shirley for giving us guidance to make this project. Thank you so much.